All right, I think we're going to go ahead and get started. So first off, thank you everybody for being here. I know we had a couple late notifications on the actual presentation date and time, and we're doing an unconventional date for BSUG anyway. Generally, they're the fourth Wednesday of every month, but there are 5 Wednesdays, so we ended up just pushing it to the end one to accommodate some schedules here around the lab. So with that, I'm very excited to introduce our speaker for today, Prasad Vaidya. I'm excited because he really actually covers 3 of the main services that the lab works on as well, and is very adept at all 3. So remember, we do research, technical consulting, and education and outreach. Prasad has some extensive experience in all 3. So currently, he's working as an independent consultant for his own company called Zenergy, and works on energy policy, program development, and net zero energy buildings. As I said before, equally adept at research and technical consulting. He has had at least 20 years in the building efficiency industry and has worked on over 150 professional projects in incorporating technical assistance and sustainability consulting with those particular projects. He's also worked on tool development, something we do at the lab as well, and also has done plenty of workshops on daylight simulation, LEED, and other types of program management. Out of those 150 projects, he started working on those early in his career as a project architect and architectural designer at the Ellerbe Beckett's architectural group and DAAT. And then after that, he moved on to the White Group and worked there for 10 years as their energy and sustainable design consultants. And after that, worked for 4 more years at the White Group as a principal before forming his own independent energy consultant group where he currently works at. In terms of education, he got his Bachelor's of Architecture from the University of Mumbai from the, is it St. J.J. College of Architecture? Sir J.J., there we go. Sir J.J. College of Architecture from the University of Mumbai. And then went on to get his Master's of Architecture at the University of Minnesota. So would you all please help me welcome Prasad to Boise. So with that, just one quick note to our online listeners. You'll be able to ask questions throughout this session. It'll be slightly interactive through your questions pane, so feel free to type in any questions. And for the audience currently here, since we have a pretty hefty online audience today, if you have a question or a comment, please raise your hand, and I will bring the microphone to you, which you'll notice is silent, but it is allowing us to be heard over our webcam. So with that, thank you, Prasad.
Okay. Thanks. So moving on, I'm going to present 2 slides over here to set some context about what's going to come up. The bar on the left over here is a typical building in California. This is based on data from the Sears database, and it operates at about 82 kilowatt hours BTUs per square foot. If you wanted to construct a net zero building, and if you were able to grab energy using PVs from your roof, basically you could build a 1-story building that could operate at about 50 kBTUs per square foot, right? And that's the budget that you have, and that's the amount of floor space that can work with the roof area that you have. And simply put, as you start adding floors to this, your energy consumption needs to go lower and lower. So if you get to a 4-story building, you need to be able to have a consumption that is no more than 12 kBTUs per square foot. This is an easy way to understand how we would respond to the net zero problem. Now, you can use this information, or you can use the information from a database or benchmarking system to be able to address this issue. And it doesn't require much simulation. Where simulation comes in is really to understand, can we meet this goal or not with the design that we have? And during design, the predictive ability of simulations is what is important. So as we go towards either buildings that have specific energy goals or owners that have specific energy goals, simulation becomes more and more important. But there's another place that simulation does become important, and I'm going to talk about that as well. Another, a context slide over here is that if you look by design phase, going from pre-design all the way to operations and retrofit, energy saving potential typically drops down as you go further into design because the decisions are already being made. And so the biggest potential is obviously in pre-design. Can you do modeling in pre-design? Can you do simulations in pre-design? The answer is actually yes. You can build a model of, say, a typical office building in Boise, and you get about 70% accuracy in your model. So you might not be exactly there, but you'd get there. And as you have more information about the building and as you build it, your models become more and more accurate, right? So we have the ability to model even when we don't know a lot. And this is another thing that I want you guys to keep in the back of your mind when we're talking through this stuff further. That's the context. Then why wider? Why do we need to have more buildings doing modeling? And why do we need to do an effort to spread the energy simulation and energy modeling ability? So there's the AIA Measuring Industry Progress Towards 2030, which is a report that came out. And that report basically said that of the large firms that were surveyed, they found that about 57 to 58% of the square footage was being modeled, and that number hasn't changed. So we're saying that less than 60% of the large firm square footage is being modeled, and the rest is just being left out. So what? Well, the next one is that the next bullet over here is from a recent book that came out by Piketty. This is related to taxes. Why do people do taxes? Why do people do tax projections? They want to know what they're going to spend in the end. And before the Revenue Act was passed in the U.S. in 1913, apparently most people didn't know what they were making as an income during the year. So if income is something that's so important for us to know about, and if energy is similarly going to be important for us in the future, we better know what's going to happen with it. And that's where simulation and design becomes more and more important. Now the question is, how do you get simulation and design to become an enforceable thing? It becomes something that's important for people to do. One is obviously a few programs like LEED, which require energy simulations during design that allows people or forces people to evaluate their building. The second is utility programs enable that very often. So people get incentives. The third is that outcome-based codes. When codes are done on the basis of whole building performance, or their compliance is done on whole building performance, that's a powerful tool to spread it. And that's actually that policy tool is really what led to the work that we did in India. So I'm going to cover that in the next half of the talk, and then move on to the deeper section is how did we do this wider thing in India in the last 2 or 3 years. So background for India is there's a lot of buildings being built. About 2/3 of the building stock that would exist in 2030 is yet to be built. That means that there's a lot to be built. Energy costs are high. Construction costs are low, which means that return on investment for energy is probably going to be a good thing in energy efficiency. There's a shortage of energy, and there's a peak demand that's not being met. So obviously, energy efficiency in buildings is an attractive option. Another background is that the energy code was developed in 2007 and is being considered in various states to be adopted as an enforceable code. What happened is that while the code is very similar to 90.1 in terms of how we understand it in various systems, and there's prescriptive and performance paths that people can use, the law in India that's written up, the regulation, the law, actually says that energy performance or energy codes can only be enforced on the basis of a kilowatt hours per meter square metric. So as soon as you read the law, prescriptive performance goes away, and all you can do is whole building performance. So knowing this issue that the law actually uses prescriptive, lets out prescriptive and only recognizes performance, we decided to use that as a policy tool to be able to launch energy simulations as a way for buildings for the building industry to start evaluating their buildings. The history before this in terms of how building simulations were used was that there were a handful of research institutions that were using building energy simulation in India. And there was a small number of projects that were going for LEED certification that were using it. The rest of the buildings didn't do energy simulation. So this became a big way to sort of launch energy simulations into the industry. And so we built a whole building performance tool that's online. We'll talk about why it was online later. It follows Appendix B, which is part of the code. And Appendix B is very similar to Appendix C, if you know what that is, in terms of a modeling protocol. It uses a Do simulation engine as a backend. And I'm going to walk through a few screens over here just to give you a flavor of what that simulation tool is like. So that's the big splash screen that comes up when you enter the software. This is where you enter information about your project and your address. Remember, this is a code compliance tool. So it has to have a lot of consistency and certain information about the building. You can choose a bunch of shapes from the building and then adjust them and rotate the shape around to your orientation. So you can take that square and squeeze it down to a rectangle if you want and then rotate it to represent your building. Remember, this is code compliant, so it's not the kind of modeling that you would do for a LEED compliant or a LEED building. It's still pretty simplistic, but it gets you into the ballpark results. That's the idea, is to get you there. And the idea is to get you start using simulations more and more. So you can do internal loads and you can do schedules. Schedules are very easy to do in a tool like this, where you can drag the nodes around to represent the usage curve for your building. Building envelope, there's 4 orientations for every building based on those shapes, and you can specify the constructions for the walls, windows, and the window-to-wall ratio. You can pick one of the constructions that you want, and in terms of windows, all you have to do is provide the window-to-wall ratio. And the simulation modeler actually puts in the windows based on that. Again, it's an approximation, but it gets you into the ballpark. HVAC systems, there's a few systems that are available within the tool that are typically used in India, and you just take one of the systems and adjust them and adjust the efficiencies and the components of it. So again, a much simpler interface and approach to doing HVAC modeling. And then, you run the simulation and it gives you results, and it tells you what your proposed design and your standard design is and whether you're complying or not. You can download or you can generate a report. And a report basically tells the official who is going to be checking your building or your design whether your building is complying or not. And it's as simple as that. So the idea behind this was that we wanted to be, the audience for this tool was that we said, it needs to be simple enough that a 5th-year architecture student without a knowledge of building physics can open up this tool and try to learn it and be able to use it and run a simulation in 1 hour. You need to be able to model your building in 1 hour. And you need to be, and for the HVAC stuff that possibly the architecture student is not going to know about, he should be able to talk to a mechanical engineer. And that shouldn't take up more than half or an hour of the mechanical engineer's time. So we're talking an hour of a student, possibly, could be an intern in an office, architecture office, and maybe some discussions with the mechanical engineer, and you should be able to get your compliance done. So the tool is being launched in India, and there are a few other smarts built into it that I want to talk about. So we're talking about code compliance now, which means that a lot of people are going to use it, and some people tend to game the system. So buildings in India very often are not conditioned for the entire year. They turn off the HVAC systems for certain months of the year. And if you allow a modeler to turn off the cooling or the heating for arbitrarily according to what they want, they game the whole thing and try to figure out how to get their building to be compliant. So we went through some algorithms to figure out, using the adaptive thermal comfort model, if somebody said, I don't want to run my system throughout the year, then the tool uses the weather file and says and decides when heating is available and when cooling is available using the thermal comfort chart. And that's all you get. You get to choose whether you want to run the system for the entire year or whether you want to use an adaptive thermal comfort model to be able to run your system. So that takes away from people's ability to game the system. This is important for code compliance. Thermal zoning is also automated. For those of you who do simulations, you know that thermal zoning, if you try to do it on a room-by-room basis, can become very tedious, and we don't want that to happen. And if you allow people just to do 5-zone modeling, which is a perimeter zone and a core zone, then you get models that are not, don't have fidelity with the building. So you need to come up with something that's in between. And so we developed a system where all they needed to do was measure the perimeter of the building and figure out what spaces there were on the perimeter. So in this case, in the diagram on the left, there's 60 meters of storage on the north perimeter. And that's all the information that you would need to take. And so for 3 floors, maybe there's 20 or 60 digits that you need to copy down based on how your building is configured. Enter that into the tool interface, and then it does the zoning by itself. So it's semi-automated, I would say. So then we get to why did we do an online tool and why did we do a whole building performance tool? So whole building performance obviously came up as a result of this Energy Conservation Act that was there. They said it has to be kilowatt hours per meter square. So, so the tool was there. But the other aspect of it is that as soon as you start doing whole building performance code compliance, it allows people to creatively meet the requirements. You're not restricted to putting in some amount of insulation or some window area. People literally can do what they want. And that's an important thing when you're trying to introduce codes into a country or into a place where they've never had that kind of regulation before. To allow them to think that they're still free to be able to do what they want, but there are certain regulations. It eases them into that regulation. Doing it online as opposed to doing it as a downloadable tool has a huge benefit in terms of the fact that people don't have to download the tool. They don't have to maintain it. All the maintenance is done at the server end, and all you get is an interface on your computer. So that means that if tomorrow we find that, the defaults that we have for the adaptive thermal comfort model aren't quite right, we don't have to have everybody else re-download the tool to get it right. We just do it on the server end, and everybody gets to use the benefit of it. So it's easy to respond to those kinds of upgrades, and it's also easy to respond to code upgrades as the code gets code gets changed through the years. And imagine the value of something like this. It builds a database in the background. Everybody's using the same tool. It's a central database. People are filling information about the amount of glass, amount of insulation they're putting into their building. And somebody who wants to do research or somebody who wants to set the next policy can look up the database and say, what are people doing in terms of window-to-wall ratios? Are we at 40% or 20%? Well, you've got the data now to be able to check that. And the value of a database like that is huge. So those are the reasons why an online tool it has so much more benefit, especially if it's being used by a very broad audience. An online tool definitely means that it's going to be more simplistic than something that you can have on your desktop. But that's the idea. Keep it simple, keep it fast, and make it and have it be usable. So I think, yeah.
So you're talking about this in the idea that in a developing country, it was really the that it was really the idea of having a performance requirement that drove the need to do this type of simulation. How do you see that fitting into developed countries where currently we mainly go through the prescriptive pathway for code compliance? Do you see that changing in the future, or do you think it will always be a certain way now that it's been established and we're already kind of on this pathway?
There's two ways I think things would change. One is that there are certain jurisdictions that are looking at outcome-based code. And if you do have outcome-based code, you will get into doing whole building compliance. So that's one path that certain jurisdictions will take place. The other is that if you make a whole building compliance tool simple enough to use, most people will choose to go with whole building than prescriptive, because then you don't have to do what you're being asked to do. You know, most architects like to think that they have freedom to design, right? Your client always tells you exactly what you need to do, but but you want to have the freedom, and whole building gives you that freedom. So if the tools are there and they're simple enough, then whole building will become the method of choice as opposed to prescriptive. Yeah.
The images, the screenshot images you showed us, that's currently being used in India right now.
Yeah.
And have you interfaced with any decision-making people in the U.S.? And the reason I ask is to, make more stringent the codes. I don't know if you spent much time here in Idaho, but that would be a pretty tough sell in this political community.
Mm-hmm.
Right now, if you do a res check or a com check for a small, simple building or a single-family residence, to be totally candid, it's kind of like a fudging exercise a lot of times. I think owners would be really happy to be able to do a whole building performance if it was simple and clean and didn't add an exorbitant layer of cost.
Right.
So my question is that I think this would be a great tool to have. And you wouldn't have to necessarily, I mean, you could make it a code that's enforced, but I think that the owner community would adopt it automatically, very quickly, faster than they would the stick. They'd adopt the carrot rather than the stick. So what's the chances of getting some online, easy-to-use software like that into my hands?
I don't know. Maybe this is a question we could throw open to the people who are doing policy work in Idaho, like Jake or Kevin, and ask them what's the chance of having something like this.
That's a better question for Kevin than Jake. but we are working on some tool development with Idaho Power. They're helping fund some of our educational program, BSUG, but also some tool development. And the idea behind that has always been multifaceted. Some to kind of encourage early conceptual energy modeling or energy analysis per se, with some very integrated spreadsheet automated tools. And we've had a lot of conversations on where that might lead in terms of bringing it more to the masses, what that might lead to in terms of incentive program development and even policy implementation. But we're still kind of in the first layers of doing that type of tool development.
Can I go online and use the Indian version?
You can, but sorry. Go ahead.
The question is this tool that Prasad just presented available to us now here in the States?
The tool's available to anybody who wants to log in. It's free. However, how would you use it? It's based on code, and it's based on building industry operations as well as construction practices of India. So you'd get something that's probably not relevant for the United States. Yeah. I mean, if you just wanted to learn simulation, you could probably do that. So, which is the next question that I want to ask, at least the audience who are in the room over here. How many of you actually do simulations? about half of you guys. And then the rest of you end up using simulations as a result of somebody doing them for you? Yeah? So you use energy modelers or consultants who are third parties who would help you. Okay, got it. And then what is the primary reason for those of you who are doing simulations on projects to do them? Why? Okay. Anybody else? Same answer? So what's the most frequent? What's the most urgent or imperative? What is the imperative out of all of these three things that you mentioned? Is it lead that drives it most often? Is it code compliance that drives it most often? Or is it the third one that you mentioned? Performance.
And based on our firm, I think we're starting to shift towards design. It used to be almost completely driven.
Okay.
People are starting to see the benefit of design.
Okay. Cool.
And also, so the lab conducted a building simulation market assessment in 2012, throughout the year of 2012, that looked at both architecture firms and engineering firms and some of the motivations behind them using simulation. And I believe that we were starting to see it even out in terms of lead compliance was still, the top.
Yeah.
And then a close second was just design assistance and trying to design more efficient buildings.
Okay.
And then there were some smaller ones, which was like client-driven and code compliance-driven.
Okay. All right. So just a quick summary on the process that we use, I'd say, to go wider in the case of India is, first of all, we had a legal framework that we could leverage, that we could base this on. That was an important step to have, to step over. We made the use easy and reliable, and I think both of those are important. It's easy as well as reliable. If you can't have consistency in modeling, then God help you. We engaged with stakeholders and experts to review the outcome. So there was a review process where we had users, a user group as well as an expert group who looked at what the tool was doing, was it okay or not. And as part of this, we will also work closely with one of the universities in India who gave us a lot of the information in terms of how buildings are operated and what's the construction technologies that are used in buildings that made the tool more relevant. And then there's a few people who are currently working at the state level for ECBC, which is the code. Its implementation is happening at the state level, just like it happens over here. Each state decides to put its own code in place. And the requirement to use the tool is being written into these roadmaps. So the first bullet and the last bullet are actually policy level work that needs to be done to be able to enable a broader use of the tools, or to be able to make it be something that's broadly used. And the two bullets in between are more of the technical stuff that one needs to do. And it's important to be able to do all of these things. So next, we go into the deep portions of energy modeling, and this is the FLEXLAB facility for low energy experiments and buildings. Nice little hill in the background in Berkeley, and then there's just these buildings in the foreground over here. So I'm going to talk about this. And first of all, why do we need to go deeper? My thought on this is that we've had studies, NBI has done them, Lawrence Berkeley has done them. We know about these studies that show the discrepancy between what was modeled in terms of energy results during design and what was actually done, what was actually observed in operation. These lead to the perception that modeling is not accurate or is not reliable. I don't agree with them, but that's what people think. Design models are not meant to be used for comparing with performance. It's like saying, if I go to my tax consultant 9 months before I pay my taxes and say, what are my taxes going to be? He's going to be somewhere in the ballpark, but he's not going to be able to nail down the taxes. I can't compare his predictions in June with what I file in March. And that's what we're doing with some of these studies. Be that as it may, there are problems with energy simulations. And I think those of us who engage in those should, let go of our hubris and say, yes, there are problems. Low energy designs often require what we are calling workarounds. right? Systems can be represented. There's something that happens in a building, new design technology or solution comes up. You want to open the windows for a certain amount of time, and it just becomes messy. And so those things aren't well represented in our simulation programs. There's owners who want guarantees of savings. So there's now a pressure and a risk that people are feeling when they're doing modeling. And given all of these things, the market pressures that are there, we can't treat energy simulations as research during design. It's about informing the design. It's about being responsible. And so it would be nice to be accurate. So can that happen? There have to be ways to be able to do that. And FLEXLAB is one of the things that I think can help us to get towards more deeper and more reliable, accurate energy models. So up here you're seeing a view of the campus, portion of the campus. That big building in the background over there is the building 90, where the energy efficiency, environmental technologies people sit. The top floor of that, which already exists, has now been retrofitted to become what's called the lighting and plug load test bed. So it's got a bunch of controls and different types of systems and sensors, so that you can do controlled visual comfort and behavior studies if you wanted to look at, what happens when I do this, and there's, do people reduce their plug loads or not? So those kinds of studies can be done up there. There are these other ones over here down that are new test beds that have been put at LBNL. These are physical new buildings. There are 4 of these, 1, 2, 3, and 4, that allow you to test integrated systems and components. Basically, what your energy model does is what this facility would be able to do. Each of these test beds, 4 of these, can be divided into 2. So if you want to do comparative studies by holding one as, say, the code base or some other baseline, the other one is your design, you can do a comparative study. And then there is what they're calling the virtual test bed. The virtual test bed, as you can see, I'm not pointing to anything specific over here because it's virtual. It's the data that comes out of all of these experiments, and being able to access them and on a platform that can be used for designing modeling. So but you're basically using the stuff that comes out of the physical aspects of the lab. And it's staffed by LBNL scientists and technicians who are often the people who have been writing the simulation programs that we work with. So when you work with FLEXLAB and do something there, you have the ability to access that expertise. So what FLEXLAB can do, it's test integrated building system solutions. I'll get to that a little more in the next 2 slides. It tests it under realistic operating conditions because it's actually out there in the environment. It's not really inside a lab, and it can do it fast. So they have techniques of being able to study an entire year in a month period by manipulating the building. Going back over here, one of these test beds, this one, actually sits on a circular track, and the whole building rotates. So you can look at different orientations if you wanted. So you can demonstrate and assess whole building systems integration. How does my lighting interact with my cooling system, or what happens with the humidity controls when I put chill beams in my room or something. You can test equipment components and operating sequences, so you can test those as well. And you can calibrate your simulation tools because everything is monitored really well. The question is, can this really be used in a design practice or on a project? And that's something I think that's up for discussion right now. So you've got interchangeable facade elements. You can change out the windows or the walls, change out the insulation values, put a different type of shading design in. And you could even do a double skin facade if you wanted to and test it out. You've got a flexible interior space, so you can raise the height of the space or change its dimensions. And put in interior furniture that you wanted. You can also change the interior load. So if you wanted to represent somebody who's on a running track in the room, they have these dummies that produce more heat as opposed to somebody who's just being sedentary. You've got interchangeable HVAC systems, so air side and water side systems are available, so they can be interchanged. And you've got lighting that can be changed around, and a lot of controls. So, as I said, it allows you to do side-by-side comparison within each test bed. So you can build 2 or maybe even 3 different options. You can do controlled environments. So they have the ability to be able to raise temperatures inside or drop temperatures inside to get a delta T between the inside and the outside that would represent your climate that you're trying to do this. There's limits to what you can do, but it's a pretty large section of the United States that gets covered under what FLEXLAB can do. And they've got a lot of instrumentation for high granularity power and measurement and high accuracy sensors. So it means that walls have sensors and then temperature sensors, humidity sensors in them. Additional sensors can be added at any point. So if you want to look at what's the temperature of the glazing of a specific glazing when I have an HVAC system in there, you could test that too. The lighting and the plug load test bed, which is that entire floor, is actually something that is being used by the researchers. This is regular office space, and that's why you get to do behavior studies in this. And so it's a 3,000 square foot space, lots of lighting zones, and for occupancy sensors, daylighting sensors, so you can change the granularity of your control, and a bunch of monitoring that happens at the individual desk level, or it could be at a group level. And individuals can control their environment as well. So it gives you some flexibility. The virtual design test bed has some infrastructure. So the idea of this is that data gets generated out of these experiments that are done, and eventually you want to be able to use these experiments to be able to look at them and see whether you've got something that's represented in there or not, or you need to do something new. So there's simultaneous platforms that can be used. So the way it's set up is that if you wanted to have a design charrette, you could use a bunch of the data that's already there, and some of the simulation tools that are in FLEXLAB. And rather than doing that design charrette in your office, you could just log into all the servers that are here and access that information. So here's the thought. Our pre-design through occupancy timeline. Typically, you've got the owner. This isn't showing up really well. You've got the owner that gets involved early on, and then hands off the project to the design team, and then back there, the owners in occupancy involved again. The architect engineer is involved in the middle. You get the contractor that comes in typically after bid and stays on till the beginning of occupancy. And then you've got the commissioning and testing agents who come in sort of towards that end of construction phase. This is our typical design construction process. So high value feedback typically through modeling is given over here during the pass-off between schematic and design development. But then there is also a lot of stress on the design team at the time, or on the owner at the time of bid and at the time of commissioning. So these are, I think of these as the place where often the rubber meets the road for energy design. And the vision over here is to be able to compress all of these into something in this phase. So what FLEXLAB potentially could do for a new construction project would be that instead of building a mock-up on your site, you could have a mock-up be built at LBNL's test lab. And that could happen during your design development process. Maybe it's up for 90 days. And there's a whole bunch of testing that you want to do because you want to be able to guarantee energy performance. So you get the ability to test your systems, calibrate your simulations really well, and bring in maybe the bidders and maybe the commissioning people right on early in design so that they're familiar with the system. You could maybe even bring in the users or the building operators, and they get to test, feel the systems or how they're operated, how they interface with the EMS system works. And all of that high value feedback then is able to reduce some of the stress that happens over here. Maybe the bidders feel like they know the system, so you might get a more competitive bid. The commissioning people feel like they already know the system really well, so maybe their work becomes easier. They write tests that the bidders are able to see that are more relevant to the system because they've actually seen it. So this is the kind of value proposition that may be possible for a project to be able to use FLEXLAB. So just a couple of use scenarios. New construction, obviously, I explained that design optimization and calibration of models can happen. And then test driving of the mock-up can happen by owners, operators, users, etc. But then for portfolio owners, those who own large sets of buildings, they could potentially test operational retrofit strategies that represent their portfolio. You know, you got a building in, say, Idaho, another one in Washington. And you could test both of those because you could represent those scenarios in FLEXLAB. So that's a potential. And before an owner sets an energy performance goal, they might have the ability to go into FLEXLAB and say, I want to get down to maybe 20 kBTUs per square foot. Is that realistic? What's it going to cost? And they can set realistic goals now, and their design teams would feel a lot more relieved about that. There's also non-project specific use, new technologies and standards. Utilities are doing emerging technology programs where the testing of those new technologies can be done here. Manufacturers can test their technologies. Now we're talking about integrated testing as opposed to just what does my HVAC system do if it's by itself. You can actually look at what does my lighting system do and how is any given HVAC system responding to it. There's validation of design, simulation, and operation tools. I think this could become an important thing as, you know, maybe Energy Plus gets more algorithms that are written for different components that are produced in the market and they can be validated here. Comfort and behavior studies could be done more reliably, perhaps. And then there's obviously the training for designers, contractors, and operators. So each time you have a new combination of systems that are put together, potentially LBL could say, we're throwing this open now for the next few days for people to get a feel for the systems, and they could invite people to come and get trained over there. So these are some of the ideas that are there behind FLEXLAB, and I think going back to the idea of deeper simulation, having a facility like this, whether a lot of people use it or not, as long as the data is made available to everybody to use, what happens when a certain system is used in another system. And if this type of database gets built up over time and people have access to it, it's going to lead to a real good improvement in the way simulations are done, because there's going to be a lot more calibrated situations, or a lot more system situations that will have results about to calibrate our simulation. So from that, I have questions for you now. So I give some value propositions. I want to ask you, this audience, is there, given the scenarios that I talked about, or maybe even thinking beyond that, outside the box, when you're thinking of projects, maybe a client who wants to do something different, do you see that you might be able to use FLEXLAB, and what's the kind of value that you would expect out of it? Yeah.
Well, I think that the value is potentially increased the greater the integration with things like cost, whether that's performance or whether it could be integrated with an LCA or some other potential. Because, quite frankly, that the diagram that you showed, where there's stress points like at design development, and then that quite pronounced spike at bidding, what then follows that almost always for us is BE, which is then makes us go back to DD and cut out all of these integrated systems, not all of them, hopefully. But if I could load that information to that front end, which included at some level costs as well as performance, and then that would be the most useful information that FLEXLAB could give me in terms of an integrated long-term proposal for clients.
So to clarify your comment, I want to ask you, under a normal design process, you may have some access to cost and some access to performance. What FLEXLAB would do, what you would like it to do is to give you better information on cost and better information on performance. Is that right?
Yes, potentially.
Potentially.
Yeah. At least we could, if there's a way to begin to link them.
Yeah.
If we can model efficiencies, we certainly can make some assumptions.
Okay.
We can make assumptions about system costs up front, and we can make assumptions about operating costs. And different clients will have different needs based on their project type.
Right.
Some are going to be more concerned with the initial costs, and some are going to be more concerned with the operating costs.
Yeah. Is it realistic to even think that bringing the bidders in early on into the process would help reduce some of the anxiety related to costs down the road?
I think it depends on the project.
Okay.
I know that's kind of a wishy-washy answer, but I also want to know how accessible are the data, and if they're relatively accessible, who's using them now, both on the India online version, and I think that's clearly one of the strengths of that.
Yeah.
And then with FLEXLAB.
Right. So in the Indian online version, the Bureau of Energy Efficiency, which is the central body, it's sort of like EERE at the Department of Energy over here. They're the ones who have access to that data. And obviously, because it's building privacy, there's privacy issues. It's not something that could be made publicly available unless it's scrubbed. So, but that database needs to be filled in as compliance happens now over time. So I would say that maybe 5 or 6 years down the road is when the data becomes really valuable to you. With FLEXLAB, the facility is being launched right now. And part of the reason I'm having this conversation is to be able to inform LBL what value it would provide. And I think, as you said, if you have access to the data that comes out of these experiments, it would be valuable, right? And I think we can see that. So it's give them the information and say, it's not just about the data, but maybe it needs to be formatted in a way that's more accessible, more easily accessible and easily understandable. And maybe it needs to be in the form of case studies along with data. What happened and what were some of the verbal observations as opposed to just the quantitative observations. Anybody else on this? Yeah.
I think with FLEXLAB, the benefit is anything that's difficult to model, particularly like passive strategies, trauma walls, natural ventilation, that sort of thing. We're always coming up with workarounds to try to estimate it.
Mm-hmm.
Seeing real data compared with weather data would probably be the most benefit to me.
Right. So would you imagine actually testing some of that on a project in FLEXLAB, or would it be more the way she mentioned it? If the experiment was done, you'd be able to use it in your modeling of passive systems.
I think if the experiment has been done, we could probably use it as to back up our calculations model.
Okay. All right.
And to piggyback on that as well, too, I know a simulator, I think that hits the nail right on the head. So, like, for instance, double skin facades are notoriously difficult to model in most energy modeling programs just because there's such a huge CFD component in the annual energy component. So if our simulation could actually be speaking to FLEXLAB almost in real time to where it's automated in terms of like what the data that's coming out of FLEXLAB can automatically get input in the simulation, or maybe there's like maybe not particularly in real time, but to groom the outputs of FLEXLAB to be able to be easily accessible through simulation, I think it'd be really powerful as well too. So you could modify some things, get that data set, and automatically use it and put into like Energy Plus. That'd be
right.
great.
So to take your comment further, it might be even more valuable, for example, if there is a database provided of certain results for LBL to identify which of that data, especially if it's sensor-related data or sensor output, which of that is actually something that goes into simulation models, as opposed to other stuff that might be just an output of the simulation model, right? Yeah. Okay. Great. Next one. Yeah, go ahead.
I was wondering what proprietary product manufacturers, how's FLEXLAB integrating with them? Is it available for them? Can they go and say, we've got this product that does X, Y, Z. We want you guys to test it. And, is that part of FLEXLAB's mission? Is that happening? Is it planned to happen?
Did you get the mic? Or do we need to? Yeah. So are manufacturers going to use FLEXLAB?
There's going to be an ongoing relationship between the two.
Yes.
I can see if it's FLEXLAB tested, it becomes a marketing tool for them.
Correct. Yeah, and that is the idea, is to be able to make this available to manufacturers, to be able to provide results that are beyond an isolated test, in their facility, and then it also becomes third-party objective. It's not just by the manufacturer. So that's also helpful. The plan is to do that. The plan is to be able to do that through utility funding as well. California utilities specifically are very active in emerging technologies. So any new thing that comes up could be tested in FLEXLAB, and the results could be made available. The studies could be made available. So, so there's that. And in terms of whether the data is publicly accessible or not, the general tendency is going to be to make it accessible because it increases the value of the technology. But there might be certain aspects, especially if a manufacturer is testing things, that they may want to keep proprietary. And those, I think those are going to be ongoing, evolving relationships of what data gets published and what doesn't. Yeah. So next one is what challenges do you anticipate in having FLEXLAB serve the industry?
One would be maybe the cost or demand, I guess, in terms of how quick they can turn around projects. Or for instance, if I wanted them to do an iterative double skid facade study where they have to actually rebuild this facade a couple of times to use for simulation, how long does that take? How long does it cost? And when is it available?
Right. Yeah, definitely. And those are great because building projects have their own schedule and they need to have their own method of or urgency of delivery, and you can't allow that to be superseded by research questions that are more interesting because you just don't have the time to be able to do that. Anything else? Okay. So I think you did mention this a little bit of this, what technology or design strategies need to be tested at FLEXLAB. This is the reason we're asking this question is to be able to identify what is it that are pain points for the industry in terms of simulations or reliability. And I think you could probably add to some of the things that you said, but if you're interested in providing input to what FLEXLAB does in terms of research and the technologies that they test, you could sign up for it. There is going to be an industry guiding group. So you could basically put likes or votes on questions or something. Go ahead.
This as well in terms of technologies and design strategies. I think the ones that directly deal with human comfort, like radiant systems, certain types of passive systems, could really be served well by something like FLEXLAB because you've got the empirical studies which happen in a building, which, there's a lot of noise in that data, or you have the pure laboratory environments where it's non-representative. It seems like FLEXLAB can be something in between that allows it to take on more characteristics of the empirical studies, and then it can also be used for doing something complex like comfort tests, right? You can change the humidity of the space. You can change the mean radiant temperatures. You can have people go into space, calibrate their own sensibilities towards what that comfort zone or that adaptive comfort zone means.
Yeah.
So I think how it kind of serves this kind of what is generally a very squishy kind of comfort-based perceptual science is something that can be tested very rigorously.
Yeah, and I believe that could be of a lot of value to owners who get a lot of complaints from people who are using buildings and building operators. Yeah, great. So next is sort of just throwing it open for any other questions related to both topics that I covered wider and deeper.
So our practice is small projects, little budget. There's no way we're going to take something to FLEXLAB and test it.
Right.
But I can see 10, 15 years from now, having the right searchable database, we can mine the information and shop the systems, whatever type of systems they are, and then apply them. So I guess I see that accessibility to the collective data and knowledge that grows over time would be really beneficial.
Yeah. Okay. And the reason that your firm and your work would not be able to use FLEXLAB on a project is simply because you anticipate the cost to be high.
You're going to add a couple classrooms to a church in rural Wyoming.
Right.
And they pay the budget $350,000.
Right. So what are you going to do? Right. Right. Yeah. Sure. So I guess for the larger market, the value is going to be in the data that gets produced and the tests that are done, and really how well that information is disseminated into the industry is going to be critical for having a bigger impact. So it's going to be as much about, information dissemination as much as the research itself. Yeah. Mm-hmm. Yeah.
I have a question in terms of where is it at in its development in terms of the new facilities, and when do you think they might actually start testing things for commercial dissemination?
So the facility is built. It was inaugurated 2 weeks ago by the Assistant Secretary of Energy, and the first project is going to go in it's a Genentech project that's going to go in pretty soon into one of the test beds, and it's probably going to be like a 3-month testing period. So I'd say it's pretty much online right now. It's a building, and its problems and its issues are completely like a building. The users are trying to figure out how to use it, what's the schedule of use, what's the value that it brings to people, how can it serve people, and that's kind of what's going on at LBNL right now. We've got this facility. How are we going to make it available? What's the best use for it? Should I lock up this facility with a year's worth of research that I've been wanting to do as an LBNL scientist, or should I let it be open because there's a bunch of industry that's interested in putting their projects in? They're trying to figure that out, where they should go.
And this is potentially a question that may be taking longer than we have, but just some of the research methods around human behavior and comfort. Are you gathering the right, or have you gathered the right audience together, or participants, if you're testing within the facility and the users within the facility? Are those in that occupied office space members of the choir, so to speak, or are they independent auditors?
With that one lighting and plug load test bed that I talked about?
Yeah, that component, the building 90, I think.
Yeah, right, the top floor of that building. The people who work there are researchers who work on energy efficiency, but fortunately, the way LBNL's, that division is structured, none of them work on buildings.
So they're all separate. Okay.
Yeah.
Well, that's good. I just had to real, and I'm wondering if some of the information, some of the research that will be coming out of this will be peer-reviewed type of research, or will it be strictly industry related?
That's a great point. I think we need to figure that out. If it's a research that's done on a project, does it get peer reviewed or does it just get published? And I think they need to distinguish between that which was peer reviewed versus that which was not. So that's a great point. Any online questions we need to take?
There were a couple about
yeah.
There was one question about how custom can you get with the geometry, essentially. If you've got something that doesn't fit into like the cross, the square, the rectangle, is there a way to do custom geometry in thermal zones, or is it always about finding just generally the right fit?
At this point, it is about finding the right fit, and I'd say the customization is in your mind. You've got a building that's a trapezium. Can you live with the fact that it can be represented as a rectangle? Because you have to remember, this is code compliance energy modeling. It's not where you need to adjust it to the last degree of orientation, or 15 degrees. So yeah, the short answer is that there is not a whole lot of customization available right now, but maybe this tool will get taken into the future where more and more details may be available. There's a flip side to that. As soon as you give people a lot more control over what they can do, you make the tool complicated to use. So the beginners then are left out of it. Because the same question can be asked about HVAC systems, or what can I do with a shading device. Right now the tool only has, here's my projection that I have from the wall, and this is how tall my window is. Now if you want to do an angular device or something else, that makes it more complicated. So is that it? Okay. All right. Thank you, everyone. Yeah.
Number two,